This tutorial will illustrate how to use some of the selected evaluation phase available in PX Perform Extension, which is an extend pre and post-processing software for Perform 2D. After extracting results from the extraction phase, the user can combine, summarize, and evaluate the structural response by using the evaluation phase. To use this one, you can start with user manual. To see the step how to use the task in evaluation phase. Let's show in chapter 4 evaluation phase here. You have the step-by-step procedure that you can follow. The second issue, you need to prepare the input file. Input file mainly for the evaluation phase. They will contain two main folders. First is a global response. Second is a local response. This one is contain some sample input file that you need to prepare. Before you use this folder, it is a good idea that you need to copy this folder and paste to the new location and start to use this folder for those locations. So let us start with the first one. The first task is StoryDip transient envelope. We show in here. To use a StoryDip, you need to prepare two types of input file. The first one will be the StoryDip output that can be obtained from the extraction phase. This is some sample of the result output from the envelope, not from time history. The second one, you need to prepare echo file. This can obtain from the Perform model folder. The last one will be Excel StoryDip. In this Excel, we have only one sheet that you need to prepare. For this set of columns, it will be information from the group of the StoryDip, the StoryDip name, direction, elevation, and for level. For this one will be the name of car motion that you need to prepare. This name, you need to map with the name of the file that you prepare. After finish preparing this input file, you just copy the path here, paste in here, and select the StoryDip transient. You also can customize the limit to plot the StoryDip. This one is depend on the design criteria. So it's time to run. Software shows some warning. Some files are missing or number of car motion doesn't match. Please check. In default, they will show 11 car motion. But input they have only 7. You just change here to be 7 and run. The time for evaluation and summarizing the result, it depends on the location of dip and number of car motion that you use, because all information need to prepare in Excel. It might take a bit time. After finish, you can back to check the Excel file. At the first time, you prepare only one sheet. Now PX generate another sheet. This one is StoryDip in H1 direction. You provide input information 3 with 7 guard motion. If you summarize here, this is the average result from 7 guard motion. In Excel, it not like only the value, it also contains the formulation that you can track back how PX calculate those formulation, those value for you. They have the limit show here, this relation show here, and table of this relation also summarize here. This graph actually is the same graph for the story dip along the height, include the limitation. This one contains all guard motion plotting with the average. This one we have average only. The graph will be a good format that it will be ready for you to just copy and paste in the report. You can imagine if you have to prepare this information by yourself, you need to copy to Excel for each guard motion and manage for each location and do average, prepare the limitation and plot the graph according to the number of guard motion that you want to evaluate. It will take a lot of time. By using PX, it will save your time and easy. The second task will be solid shear. Again, solid shear you need to prepare two types of input file. First is the section cut result of the shear wall. This is the result from the section cut for shear wall or for the all section cut. The second file is the echo file obtained from the perform model folder. The last one will be Excel file, shear. For this file, you need to prepare two sheets. First sheet will be information of the section cut and wall group, the direction to plot. You will include capacity of the wall leg or not, and the level to plotting. The second one will be the time history name that should be mapped with the input file here. The second sheet will be the capacity for each shear wall leg, that will be the dimension, thickness, strength of material, and the stirrup that provide for shear wall shear. After you finish prepare this thing, it's ready to run for the evaluation of shear wall and story shear. Paste the part in here, choose shear wall shear here and click run. Again, it depends on the number of guard motion that you want to summarize and evaluation, and number of wall leg, number of section cut in your structure. If you have many number of section cut, many story level, many guard motion, it will take more time as it like this information in Excel. But to do this one, it's better than you need to summarize all information by yourself, as Perform doesn't provide this tool for you. you can back to see the shear wall shear here. This is the first two files that you need to prepare. After that, perform we generate another sheet. This sheet is story shear in X direction. This is in Y direction. This one will be the time history resolve for 7-car motion, and they have the average here, average here. For the shear wall shear leg, you can combine the capacity also. This one plot 7-car motion here, and average result again the capacity and the limit of shear wall. This one remove other car motion, remain only the average demand. The good thing in this one, it will show you also which location that the demand exceeds than the capacity. In this case, if you want to fix this problem, because the shear wall shear capacity it doesn't enough to receive the load, you can add more stirrup, add more horizontal reinforcement. For example, at the first time we might use only 2 legs of the reinforcement. Now we change to be 3 legs and back to see the result. Now the capacity is increased. You can recommend to the client to increase the reinforcement, for example. Because all value in here, it contains the formulation that you can track back how PX calculate for you. This is a shear wall shear and story shear based on section cut. The third task is shear wall axial strain. For shear wall axial strain, you need to prepare 2 types of input file. First is the axial strain result here. Second is the Excel file. In this sample, they have only 3-car motion. In Excel file, again, you prepare axial strain information, location, and story for plotting the graph. The second one will be the car motion name. Even you prepare here 11, they will use only T as the input file that you have, but the name should be exactly mapped with the input file that you prepare. Ready to run? Copy here and check for the shear wall axial strain here. You have T-car motion, change here to PT. You also can customize the compressive strain limit and tensile strain limit based on your design criteria. Click run. At this sample, they have many locations of shear wall axial strain. It will take long time to run. As always, value need to summarize in Excel. This one it take more time because the part still not correct. It also show you something wrong because the part not correct. Okay, we just copy the part again. It should be axial strain. After the part correct, the program can run. As this file it seems to be take very long time to evaluate. I prepare the sample of the axial stain. At the first time you prepare only one sheet. After that, PX will generate the other sheet depend on the location of axial stain. In this sample, have 11 gram motion with the average here, limit shown here. Similar with the other result summarize, they will have two graph. Actually, based on these two graphs, it will be exactly same. But this graph remove the other gram motion, remain only the average and the limit. If you have to prepare by yourself for each location, it will take a lot of time to do average, also to plot the graph. If you let PX to do this task, to do this tedious task for you, it will be easy and faster. Then we move to the next task, beam moment hinge rotation. In beam moment hinge rotation, you need to prepare the type of input file. First will be the moment hinge rotation result from the analysis. In here they have T gram motion. For each gram motion, you need to prepare for node I and node J. Echo file from the perform model folder, and beam rotation Excel file. Same with the other result type and the number of gram motion. This one that you need to prepare. If you ready, copy the part and paste in here. If you don't change the part, it's like a previous sample that it will not run. This one have 3 gram motion. Check 3 gram motion and click this one. In case that you click T task and run, the program will automatically show you warning, let you know that just select only one task. Here, the moment hinge rotation and run. Again, as this structure, they have a lot of beam. One beam they have 2 moment hinge at both ends. They have a lot of moment hinge location. It will take very long time. So I have some sample of the beam rotation that after it's summarized to show. Original, you provide only one sheet. After that, PX will generate another sheet for you. This one is a limit that pick up from echo file. This one is a rotation DCR summarize. This sample we have T gram motion. As you can see, they have a lot of beam location and moment hinge. The average is shown here with the formulation to tag back how px calculate for you and summarize of the beam rotation DC ratio here. px also plot the graph of beam rotation DCR along the height of the building with the limit that show for you. The graph is good format that ready for you to just copy and paste to your report. As I mentioned, if you have many locations of output, it will take time, and if you have a lot of ground motion, it will take more time also, as it need to write in Excel contain with formulation one by one. If we write the output in text file, you cannot see anything. You cannot track back how we calculate those value and report you. If put in Excel, you can check back because it contains formulation. The last task will be column PMM. For column PMM, you need to provide two sheets to Excel file. First is the column PMM load combination. In this Excel file, you need to provide two sheets. First is the story information. The second will be PMM load combination. The number of ground motion, it will show in here. To prepare this sheet, you can use this tag column PMM load combination. For more detail, you can back to see the user manual in this section. After you prepare the demand force here, it's time to prepare the capacity of the section in here. There are 5 sections of column in here, and with the vertical rebar, this one we will use to calculate and plot the curve for the column PMM. After finishing, prepare the input information. You can copy the part here. Again, paste in here. Click column PMM and run. It might take long time depending on the number of columns that you have. For one column, they will have many load combination that it will take more time also. After that, you can back to check the result. PX will generate one text file PMMDC. You can copy this information and open the first file here. At the first time, you prepare only 2 sheets. Now PX provide you another sheet also. In PMM DCR, you just place the information from text file. This is a DC ratio from the demand over capacity of the section. And when you check the column PMM, it will show you in here also for each section. Because you prepare 5 sections of column, it will show you file section also. The graph is ready for you to just copy and paste in the report. The DC ratio for all columns that you provide, it will show in here. And you can see, if you have to do by yourself, based on several commotion, based on several section, it will be very tedious work and take very long time that you need to prepare for the combine, summarize, evaluate the result. If you let PX to do, it will be really fast. As you can see, the evaluation phase is a tool which can help the user for combining, summarizing, and evaluating the global and local response obtained from the analysis result in Perform 3D. This is all of the evaluation phase tutorial of PX program.